Hi, this is question 5 from the AQA Mechanics 3 June 2011 exam paper. It is dropped from a height of 2.5 meters above a horizontal floor. The ball bounces repeatedly on the floor. For part A, we want to find the speed of the ball when it first hits the floor. So what I'm going to do first of all is I'm going to write down the information that we already know. So our displacement when it hits the floor will be 2.5 meters. And it's going to be a negative 2.5 meters because it's 2.5 meters below where it started from. Our initial velocity, well, it's just going to be dropped from a height, so initially it will be 0 meters per second. Our final velocity is what we're trying to find. Our acceleration is going to be minus 9.8 meters per second, and we don't know the time. So for part A, in order to work out the speed of the ball when it first hits the floor, so we just want the speed, so it's not going to have any direction. Well, we could say v squared is equal to u squared plus 2as. If I substitute in what I know, I'm going to have v squared is equal to 0 squared and 2 times the acceleration times by the displacement, so 2 times minus 9.8 times minus 2.5, and that gives us 49, which means v is going to be equal to root 49, which is 7 meters per second. Okay, and I don't need to worry about a positive and a negative because we're just finding the speed. It would, in fact, because it was going down, it will be a negative velocity, so it would be minus 7 meters per second. Anyway, part B, we want the coefficient of restitution between the ball and the floor is E, and we want to show for part 1 the time taken between the first contact of the ball with the floor and the second contact of the ball with the floor is 10e over 7 seconds. So we know that when we get to this stage, its final velocity as it hits the ground was 7 meters per second. When it hits the ground, its speed is now going to be 7 times the coefficient of restitution meters per second. So it's actually going to be, at this particular point as it bounces, the initial velocity is going to be 7e meters per second. So I'm just going to write that down. So u is going to be 7e meters per second. Okay, and also because we are looking for the time taken between the first contact of the ball and the second contact, so we're looking for the time when it contacts, so now and now, and its displacement at that point is going to be 0 meters because it won't have displaced at all, it will be back where it started. So I can say S is going to be equal to 0 meters. Okay, and I also know that the acceleration due to gravity will be minus 9.8 meters per second. Okay, so I want to know the time taken, so I'm going to use the formula S is equal to ut plus half at squared. Okay, and I know the displacement is going to be 0, so 0 is equal to and u is 7e, so it's going to be 7et, and the acceleration is minus 9.8, so half of that is minus 4.9, so we're going to have minus 4.9 t squared. Factorising that gives me t times 7e take away 4.9 t. So either t is 0, which is obvious because at the initial point the displacement will be 0, or 7e take away 4.9t is equal to 0, in which case 7e would be equal to 4.9t, which means t would be equal to 7e over 4.9, and if I see, and 4.9 over 0.7 is going to be 7, so we've got 10e over 7 as required over here. Okay, so that was part 1 of part B. Whoops. If I just box that off, and we will have a look at part 2 of part B. Okay, so it says find in terms of E the time taken between the second contact and the third contact of the ball with the floor. So let's think about what's going to happen. The initial velocity, well, when we started off we were 2.5 meters above, and we got down to here and it had a final velocity of 7, and now the new initial velocity was 7 times by the coefficient of restitution, which is 7e. It then bounced again, and now it's dropped again, and now at this second contact it now has an initial speed of 7e times e meters per second, so 7e squared meters per second. So we can say that u is going to be equal to 7e squared meters per second. Okay, so because u is equal to 7e squared meters per second, we've got exactly the same scenario as we had over here, but instead of e we've got e squared. So that means our final solution, if we work through this again, our time is going to be the same as what it was before, but instead of e it's going to be e squared, so our time is going to be 10e squared over 7 seconds. Okay, and you could work through that if you wanted to, but hopefully you can see that we're just swapping the e for an e squared. Okay, part C. Find in terms of e the total vertical distance travelled by the ball from when it is dropped until its third contact with the floor. So what we're looking for is when it was first dropped, it's travelled 2.5 meters, it's then bounced, and then it's reached another height, and then it's travelled some more, so that's between the first and second contact, and then it's bounced again, and then it's dropped again, and that's between the second and the third contact. So there's actually three phases to this that we need to work through. So I'm going to start with phase 1. So phase 1, and phase 1 is going to be this part here where it drops 2.5 meters. So at phase 1 the distance is going to be 2.5 meters. Okay, now I'm going to have a look at phase 2. Okay, so for me phase 2 is going to be when it touches the ground for the first time, and then bounces up and then drops again. Well, let's think about how we can work that out. So it's dropped 2.5 meters, it's now bounced, and it's going to reach a maximum height. And if I know what that maximum height is, I can then double it to work out the total distance it's travelled in that phase. So during this second phase, once it's bounced and hit the ground for the first time, we know that its initial velocity at that stage is going to be 7e meters per second. So in phase 2, u is going to be equal to 7e meters per second. Okay, and we also know that when it reaches this maximum height, so when it's bounced, it's hit the ground, it's reached its maximum height. At that maximum height, the velocity, because it's at its maximum height, the velocity is going to be 0 meters per second. So its final velocity is going to be 0 meters per second. Okay, we also know the acceleration is going to stay as minus 9.8 meters per second. And we want to know the distance that it's travelled, so we want to know what s is. So I'm going to use the formula v squared is equal to u squared plus 2as. And v squared is going to be 0. U squared is going to be 49e squared. And 2as is going to be take away 19.6s. Okay, so that means 19.6s is going to be equal to 49e squared. And s is going to be equal to 49e squared over 19.6s, which is going to 19.6, which is going to be 5e squared over 2. Okay, so I'm just going to tidy things up a little bit to give myself a little bit more room. Okay, that's better. So s is equal to 5e squared over 2, which means my distance travelled in the second phase is going to be equal to, and I'll just remind you that our first phase was 2.5 meters. We've now worked out from when it bounces for the first time to reaching its maximum height, which is that there, it's now going to travel that distance again before it hits the ground for the second time. So that distance travelled is going to be double that, which is 5e squared meters. Now, so that's phase 2. So we're now going to have a look at phase 3. Okay, and in phase 3, this is where it's bounced for the second time. Its initial velocity is going to be, or initial speed I should say, is going to be 7e squared meters per second. And we're going to do the same thing again, because v is going to be 0 and a is going to be minus 9.8 meters per second, and we're going to work all of this out. We're going to follow this process again, but actually it's going to be exactly the same, but instead of e this time we've got e squared. So our distance, instead of being 5e squared, our distance is going to be 5e squared because we replaced e with e squared. So our distance is actually going to be 5e to the power of 4 meters. Okay, and just to clarify, e has now been replaced with e squared, which means e squared must be replaced with e to the power of 4 over here. So our distances that we've found, well, we've got 2.5 meters in phase 1, we've got 5e squared meters in phase 2, and we've got 5e to the power of 4 meters in phase 3. So we can now write down our solution to this, because our total distance is going to be equal to 2.5 plus 5e squared plus 5e to the power of 4 meters. And that's it for part C. Now part D, and I'll do part D over here. We need to state a modelling assumption for answering this question other than the ball being a particle. So there's a number of things that we've assumed. One of the things is that we've said that there's no air resistance, so that's the one that I'm going to go with. But some of the other things, well, we've assumed that that when the ball bounces and then changes direction, there's no time taken in that, so we've assumed that that's happened instantly. In reality, when a ball bounces, there will be a couple of seconds, well, not a couple of seconds, a couple of milliseconds where it's going to change direction. Or we've also assumed that, well, when a ball bounces, there will be a sound, and there would be some heat produced, so there will be some loss of energy there, and we've assumed that there's no loss of energy as well. Okay, so those are some of the assumptions that we've made. Hopefully you've found that useful. Thanks very much for joining me. I look forward to seeing you again soon. Take care.